Hey guys, welcome back to the channel. So today we'll be talking about the problem called Twosum. The Twosum problem is a very famous problem that has come up in a lot of company interviews, right? Google, Amazon, these companies have asked the Twosum problem a lot. So what is the Twosum problem? Well, the Twosum problem is where you're given an array of integers called nums and you're given an integer called target. And our goal is that we want to return the indices of the two numbers such that they add up to the target. We can assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order, right? So then we're given three examples for this problem. Let's look at example 2 a bit more in detail so that we can find out what the question's actually asking, right? So let's look at the input. Well, the input is that we will give the input was the array of integers nums, right? In this case, we have the values 3, 2, and 4. And then we were given our target integer, which has the value of 6. Well, looking at this problem, I can see that if I was to add 2 and 4 in my array of integers, I would get the target value 6, right? So then that's exactly what the computer did as well. It added 2 plus 4 and it got 6 and it gave the output 1 comma 2. Well, how did we get 1 comma 2? The reason we got 1 comma 2 is because if I was to look here, 2 has the index value of 1 and 4 has the index value of 2. Hence why we got the output of 1 comma 2. But let's break down this problem a bit more because there are two ways to solve this problem. The first way is kind of right, and then there's the right way, right? Because the first way that you could do it is you could do it using brute force. Now, if we were to do it brute force, the technique for brute force is that I would select my integer value, right, which is in this case 2, and then I would add it or compare it to all the other integer values in my array. So what would I do? I would do 2 plus 1, 2 plus 5, and 2 plus 3, right? And I would compare it until I get the target number 4, right? So I do 2 plus 1, which is 3, 2 plus 5, which is 7, 2 plus 3, which is 5. I didn't reach my target value, so then what would I do? I would then go to my next integer value, which is 1, right? And now I would compare 1 with every single other integer value in my array. So 2 plus 1, 2 plus 5, 2 plus 3. So then I would do 1 plus 2, which is 3, 1 plus 5, which is 6. Then I would do 1 plus 3, which is 4. Obviously, brute force would give you a guaranteed answer, right? But the time complexity for brute force is O(n) squared, which is something we don't want. What we want is the time complexity of O of n. Besides, there's a better way to do this, which I'll explain right now, which is called a one-pass hash map way, right? So how do you use this technique? The way that you use this technique is that we would loop through the array and we would calculate the complement, which is equal to the target minus the current number. And then we would compare that complement to the values present in our hash map table. If the complement is in our hash map table, then we have found our answer. Else what we would do is we would take the value and its index value and we would put it in the hash map table and move onwards in the array, right? This way would allow me to only do one pass in the array and I would be guaranteed an answer, right? So now let's look at how to do this properly. Let's start off. So we start off with our index value of 0, which has the value of 2, right? Since the target value is 4, the complement would be that I do 4 minus 2, which gives me the value of 2. Now I would check if the complement is in our hash map table. Right now our hash map table is empty. So obviously 2 is not present in the hash map table. So what would I do is I would write down the value, which is 2, and the index value, which is 0. Then I would move onwards into my array. So now we would be at the value 1, with the index value of 1, right? So now I would calculate the complement, which is target minus current, which is 4 minus 1, which would give me the complement of 3. Now I would check 3 against my hash map table. As you can see, 3 is not present. The 3 value is not present in my hash map table. So now what would I do? I would write down the value 1 and 1. And then we would move onwards in our table. So then I would do 4 minus 5, right? This is 4 minus 5. 4 minus 5 isn't present because that would be minus 1. Is minus 1 present in our hash map table? It's not. So I'll copy down the values. The value is 5 and then the index value is 2. Right? Now we're on to index value 3 with the value of 3. If I do 4 minus 3, right, using the complement formula that we have, I would get 1. So if I check my hash map table for the value of 1, we can see that the value of 1 is present in our hash map table. So that means we found our answer. And what is our answer? Our answer is that if I was to add the index value of 3 and 1, I would get my target value, which is 4. So what if we were to break this down into the coding problem, how would I do this? So the first thing that we would need to do is we would need to initialize a hash map that is empty, right? We don't need to put any values in the hash map table when we start, right? And then I would want to, since we're given nums, right? We're given nums, I would want to separate nums or enumerate nums so that I can get the index value and the value separately, right? So we would enumerate so I get I and N separately. Then what I would do is I would calculate the complement, and then we would write an if statement to see that if the complement is present in the hash map, return the values of the complement in the hash map table and the current index. Or we would exit out of that if statement, and we would then we would do what we're doing, right? Which is we would add the values to the hash map table and move onwards. So let's write this in code. So let's initialize our hash map, and the hash map is equal to an empty hash map, right? Because there's nothing in our hash map. Then what I would do is I would write a for loop in which we would enumerate our values from nums, right? So now I have I and N separately, right? So now I can do what we need to do, which is we want to calculate our complement. So what is our complement? Our complement is equal to the target minus N, right? And then what we want to do is we want to write an if condition, and that is if the complement is present in the hash map, then what do we want to return? We want to return the hash map complement index value and the current index that we're on, right? Or we want to break out of this if statement and we want to say we want to return, or we want to say that we want to do the hash map hash map value that was in the hash map is equal to I. And then we want to just write a simple return. We don't need to write this, but we'll write it anyway. And if we run this, we'll see that is equal to I, right? We'll see that we would pass every single test case. Oh, I made a mistake. I keep writing these. Alright, hash map, right? If we were to do this, we would see that our test results are valid, right? We would pass every single test result, right? So we can submit this and we would see that we come in the top 1%, I think. Oh, we come in the top 100%. We beat 100% of the people, right? Because our runtime is really good and we have the best uh, the best complexity, which is O of n, right? So I hope you guys liked this tutorial, this walkthrough. And if you guys have any lead code problems you want me to solve, please let me know in the comments. And yeah, that's about it. See ya.